Okay, so we just completed a couple of different games of rock, paper, scissors. Now, the major difference between the two was the first game, you could play whatever you wanted, in whatever order you wanted. It didn't matter. Now, the second one, you had to think about what you were going to play for the next turn because you couldn't play the same thing twice in a row. So the second game was a little bit more challenging because you had to actually think about what you had played the previous turn. So that's kind of what we're going to get into today, where we're talking about the probability of multiple events. This is a continuation kind of off of the probabilities that we already covered, where we were talking about one event where if you were going to pick a marble out of a bag, what was the probability that you'd pick a green one? Now we're going to do multiple events. So you'll be picking a green one, and then maybe you're going to pick again and you want to pick a purple one. So there are two different kinds of situations that our events can have. Our events can be independent or they can be dependent. If our events are independent, then they don't affect each other. So our first event doesn't affect our second event. So if two events are independent, one event does not affect the second event. So an example of this would be our first game of rock, paper, scissors. Your first event didn't determine your second event because you could pick rock, paper, scissors for both events if you wanted to. So this pertains to our first rock, paper, scissors game. Another example is, say we have a bunch of juices and we have a bunch of granola bars. Say we're going to pick a juice and we're going to pick a granola bar. Does picking a specific juice matter when you're picking a granola bar? No. So the two events are independent of each other. So to find the probability of event A and event B when they're independent, we're going to take the probability of event A and we're going to multiply it by the probability of event B. So that goes back to finding the individual probabilities that we did in 11.2. Now, our events could also be dependent. So this means that one event will affect the second event. So this is more, an example of this would be our second rock, paper, scissors game, where we can play rock, paper, scissors for the first time, for our first play, but then our second one, we only had two choices that we could make because we couldn't pick whichever one we had picked for the first turn. So another example of this would be, say we have a bag of marbles and we want to pick out a green marble. So we pick out a marble and we hold on to that marble and then we go to pick out another one. Well, our set has changed, right? Because we kept that one marble. So we don't have as many in our entire set, so the probability is going to change. So depending on what you did in that first pick, it's going to affect your second pick. So if we're looking for the probability of A and B when they're dependent, you're going to have the probability of the first event multiplied by the probability of the second event but we have to take into consideration what happened in the first event. So it's the probability of the second event after the first event has occurred. And we'll see an example of this in our examples on the next page. So if we go to example 1, example 1 is just asking us to determine whether the events are independent or dependent. So for A, it says that Kathy draws a 4 from a set of cards numbered 1 through 10 and rolls a 2 on a number cube. So are these events independent or dependent?
Independent.
They're independent because it doesn't matter what card she draws. The card that she draws isn't going to affect the roll of the die. So these are independent events. Now B says, Mary chooses a game piece from a board game, and then Jason chooses a game piece from 3 remaining pieces. So is this independent or dependent?
Dependent.
This is dependent because she's choosing a piece first, and then he has to choose from the remaining pieces. So this is a dependent event. C, Yuki chooses a book from the shelf to read, and then Jeanette chooses a book from the books that remain. Independent or dependent?
Dependent.
This is dependent again, because she's picking a book, and then Jeanette has to choose from the remaining books. Now example 2 actually goes into starting to find some of these probabilities of multiple events. So example 2 says events A, B, and C are independent. And probability of A, probability of B, and probability of C are all given. They've already found them for you. So we need to find the probability of each combination of events. So example A has the probability of A and B. So from our definition, the probability of A and B equals the probability of A times the probability of B. And we're given the probability of A, and we're given the probability of B. So we just have to plug in the 2 decimals that they give us. So the probability of A was 0.4. The probability of B is 0.3. And when we multiply that out, we should get 0.12. And we can translate that into a percentage. That would be a 12%. So there's a 12% chance of event A and event B happening. Now B wants the probability of A and B and C. So this is taking the probability of A multiplied by the probability of B multiplied by the probability of C. And again, we're given each of those probabilities, so we just have to plug in the numbers. So again, probability of A was 0.4. Probability of B is 0.3. And the probability of C is 0.15. And when we multiply that out, you should get 0.018. And again, if we translate this to a percentage, you're going to get 1.8%. So there's only a 1.8% chance that all 3 events will occur. Now example 3 is a more realistic problem and something that we actually have to find the probabilities for. So example 3 says, at a picnic there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and fat-free chips? So we need to pick what event A is. So event A, we'll say, is picking a diet drink. And then we can call event B picking the fat-free chips. Now we need to determine, are events A and event B, are they independent or dependent? They're independent because it doesn't matter whether we pick a diet drink and when we pick, like picking a diet drink doesn't affect picking a bag of chips, right? So that's why it's independent. So events A and B are independent. So to find the probability of A and B, again, we know that this equals the probability of A times the probability of B. So we need to find the probability of picking a diet drink, and we need to find the probability of picking fat-free chips. So, probability of A. And again, this goes back to our probability section, which was 11.2. So we need, for picking a diet drink, how many diet drinks do we have? There's 10. So that's what we're interested in. So that goes on the top of our ratio. And then the bottom is how many drinks we have total. So we have 10 diet drinks plus 5 regular drinks. So we have 15 drinks total. So that sets up our probability of picking a diet drink. And we want to get that into a decimal. So this is going to equal 0.667. And then we need to find the probability of B. Now the probability of B is finding the probability of picking fat-free chips. So again, how many fat-free chips do we have? We have 8. And we have 8 fat-free chips and 12 regular chips. So we have 20 chips total. So again, we want to get this into a decimal. And you should get 0.4. So now we have our probability of event A, and we have our probability of event B. So now we can plug these in over here. So event A was 0.667, and then we're going to multiply by event B, which was 0.4. And when we multiply that out, we get 0.267. And then we can translate that into a percentage, which is 26.7%. So there's a 26.7% chance that you'll pick a diet drink and you'll pick fat-free chips. And then with example 4. Example 4, you have a bag that contains 6 red marbles, 4 blue, and 5 green marbles. A marble is picked at random and is replaced. Then a second marble is picked at random. We need to find the probability of each of the following events. So part A wants both marbles to be green. So we can say that event A is our first marble is green. And then event B, our second marble is green. Now, we're picking out a marble at random and then we're replacing it. So are these events independent or dependent? They're independent because we're putting the marble back, so our set's not changing. Even though we've drawn that one out, once we put it back, our set is the same. So we need to find the probability of A and the probability of B. So, probability of A. So we want our first one to be green. So we have 5 green marbles, and that's going to be over our entire set, which is 6 red plus 4 blue, so that's 10, and then plus 5 green. So we have 15 marbles total. So we end up with 5 over 15. And then again, getting a decimal, we'll get 0.333. Then we need to find the probability of B. Now the probability of B again is that we want a green marble. And if we pick this first one, we've already put it back because we said that our events were independent. So this probability should be exactly the same because we still have 5 green marbles and we still have 15 marbles total. So you'll get again the same decimal is 0.333. So now we want probability of A and B because we want both of our picks to be green. So that equals the probability of A times the probability of B. So plugging in our numbers, we have 0.333 times 0.333. So when we multiply that out, we get 0.111. And if you make that a percentage, it's 11.1%. So there's an 11.1% of picking a green marble and then picking a green marble again. And then B. B says neither is red. So in our first draw and our second draw, we don't want either of the marbles to be red. So event A is first is not red. And then B is second not red. So we need to find the probability of A. So if we're not picking a red marble, we could pick a blue marble or a green marble. So we have 4 blue and 5 green. So there are 9 marbles that we could choose. And that's out of the 15 still. So again, you'll get your decimal. And you're going to end up with 0.6. And then we need to find the probability of B. And again, these are independent events because we're putting the marble back. So again, your probability for B should be exactly the same as A because we still want a not red marble. So we still have the 4 blue and the 5 green. And that's still over our entire set, which was 15. So again, you get 0.6 as your decimal. So now we want to find the probability of A and B. And again, that's the probability of A times the probability of B. So taking probability of A times probability of B, we get 0.6 times 0.6. And when you multiply that out, you get 0.36. And 0.36 is a 36%. So there's a 36% chance of not picking a red marble and then not picking a red marble again. And then C.
Can I see the rest of that word, please?
C says if the first marble is not replaced, what would be the probability that both are green? So now we're picking a marble out and we're not putting it back. So our set's going to change. So are these two events independent or dependent? These are dependent because depending on what happens in the first draw determines what happens in the second draw, or it affects what happens in the second draw. So we'll say that our first event, again, is that our first marble is green, because we want both to be green again. So event A is first is green, and then event B is that second is green. And now we need to find the probability of both of these. So probability of A, you're starting out with the whole set. So we have 5 green marbles, and we still have 15 marbles total. So we get our decimal of 0.333. Now for probability of B, now we have to take into consideration our first event. So we've chosen a green marble. We're assuming that we've chosen a green marble. So we've got that green marble and we're not putting it back in the bed. So how many green marbles do we still have? 4. And then if we have that green marble, how big is our set now? It's 14. So now we only have a 4 out of 14 chance of picking another green marble because we didn't put the first one back. So when you get a decimal for this, you should get 0.286. So now we need to find the probability of events A and B. So that again is still the probability of A multiplied by the probability of B. And we know our probability of A, and we know our probability of B. So we're going to take 0.333 and multiply by 0.286. And when we multiply through, you should get 0.095, and that translates to a 9.5%. So there's a 9.5% of picking a green marble, not putting that marble back, and then picking another green marble. So if we compare that to A, where we were putting the marble back, it's a slightly smaller percentage now because we didn't put that back. So it does matter whether your events are independent or dependent. The last page, the front and the back, is your homework. It will be on YouTube, and we're done.